Microscopic algae has been living in our lakes and oceans for 3 billion years. And although they're invisible to the naked eye, their effects are very, very, very visible. Around 300 species of microalgae are known to trigger these massive events known as blooms, and a quarter of species generate toxins which can suddenly impact water quality. Harmful algal blooms, or HABs, can cause anoxic conditions that kill fish, contaminate water supplies, and impact human health. Real-time monitoring is helping to mitigate their harmful effects. So follow along as we configure this HABs detection system. Automated monitoring systems like this one can help predict when blooms may occur and monitor conditions during HAB outbreaks. We'll start by picking our buoy platform. For inland lakes and nearshore environments, the XB-200 offers a flexible and easy to deploy option. The XB-200 is self-powered with 3 onboard 15-watt solar panels. And with over 250 pounds of net buoyancy, the buoy can support various topside and subsurface measurement instruments. Let's start with the sensors and accessories that will ensure our buoy is safe out on the water and collecting the data we need to understand HABs. First, an LED beacon helps ensure the buoy is visible to maritime traffic at night and is a regulatory requirement in navigable areas. For subsurface sensors, we'll go for the NexSens T-Node FR and YSI X03S multi-parameter water quality sonde. Let's also add a deployment pipe. This will give us easy access to the sonde for maintenance. The T-Node FR is a modular temperature string with a customizable length that allows us to measure temperature at various depths. The X03S sonde combines multiple sensors in a single instrument for simultaneous measurement of nutrients and algae. We can mix and match our sensors to measure water temperature, conductivity, pH, turbidity, dissolved oxygen, and organic matter. Collecting this data is just the first step. Because HABs can develop quickly and have the potential to be deadly, real-time data and alerts are essential to detecting blooms and informing mitigations, including beach closures and preparing water treatment plants for influxes of contaminated waters. To ensure we have 24/7 access to the latest data, we'll add a NexSens X3 data logger, which will transmit measurements to the cloud every 10 minutes. There are multiple telemetry options available, but since our system will be near shore, we'll go for the cellular option. If you're interested in getting even more data on the causes and impacts of HABs, you could scale up your sensor suite to include a weather station and light sensors, or even opt for a larger buoy if needed. You can also scale the system down to the NexSens CB-75 data buoy, equipped with a YSI EXO sonde, capable of measuring basic water quality and algae conditions. Today though, we'll opt for the simpler XB-200 setup, which gives us the freedom to upgrade in future if needed. A minimum ballast weight of 15 pounds is recommended for the XB-200 and will need a chain and an anchor for mooring. Most buoys are deployed with either a catenary or inverse catenary, that's an S-shape mooring, depending on depth, but please confirm moorings with a marine engineer. Once data has been transmitted from our buoy system, we'll want to be able to view it remotely, export reports, set alerts, and more. WQ Data Live is the online software that enables us to do this. There are different tiers available in WQ Data Live to support varying requirements. As we want to be able to set comprehensive alerts and seamlessly share our data publicly, we're going to go for the professional option. And that's it. Our HABs detection system is configured. With tried and tested systems, just like this one, deployed across the US and beyond, our easily integrated plug-and-play systems have been helping us understand HABs for decades. Check out how these systems are used around the world by viewing the videos linked in the description below. Here, Dr. Helen Balch from the University of Saskatchewan, Canada, explains how their HAB detection system has supported research and resource managers.
We're looking for a variety of indicators that can help us better understand factors that can impact water treatment. So the sensors let us see these conditions develop in real time. For example, we can see the rapid development of blooms, and that high-frequency data is really critical because the blooms can set up in hours or days. So often we can see that increase starting to occur and anticipate that bloom development using sensor data. There's a million uses for the data, and the most critical is that streaming data to support water treatment. But the data also have tremendous use in understanding shallow lake ecology and supporting different projects of the Global Lakes Ecological Observatory Network, or GLION.
To find out more about configuring and deploying a custom environmental monitoring solution, contact one of our experts today or visit nexsens.com for more information. NexSens. Better data. It's never been easier.